Next is conditional distribution is conditional distribution of a random variable given another random variable. So for a pair of random variable y and x, conditional PMF of y given x is written as fy given x is probability of y is equal to y given x is equal to x, which this follows the, if we take two events A and B, such as A is equal to x is equal to x and B is equal to y is equal to y little y, then this thing can be written as probability of B given x or B given A, that will be probability of y given y and x given x divided by probability of x given x, because this is just y given x. So this is called the conditional distribution. Conditional distribution of y given x. So fy given x is fxy, which is y is equal to y and x is equal to x. That is just a joint distribution. And g of x, which is the marginal distribution of probability of x is equal to x and y is equal to y divided by probability of x is equal to x. It's a joint distribution, so you have probability of x is equal to x. That's just going to be a marginal distribution. So in other words, conditional PMF is just a ratio of joint with marginal distribution. Now let's see a question. We roll a dice and get a number x. Then we toss a coin x times. Y is the number of heads we get. If we know x, what is the distribution of y? This is nothing but the distribution of the number of heads. This is distribution of number of heads in x tosses of coin, given x is equal to x, and x can be 1, 2, 3, 4, 5, 6. Thus y's distribution is just going to be binomial distribution with a parameters of x and p. So f of y given x is just going to be x upon y the number of heads, probability of p given y, or probability of p to the power y, and 1 minus p to the power x minus y. Now y is the random variable that gives you the number of heads you can get. It can obviously range from 0 to x. For example, you can get 0 head, then y will become 0, and you can get the probability of this using the binomial formula.